This is step 1, 1987, question 7. We are required to prove that the sum shown can be expressed in terms of the tangent of a single angle. We have sin 2 pi by 23 plus sin 6 pi by 23, etc., up to sin 42 pi by 23, which of course will be the imaginary part of the sum I am now about to show. The imaginary part of that sum there, e to the 2 pi by 23 plus e to the 6 pi by 23. And we should bear in mind here that 2 pi by 23, 6 pi by 23, 10 pi by 23 up to 42 pi by 23 form an arithmetic progression, and we should find out the relevant numbers. And so we can see here that if a is 2 pi by 23, d is 4 pi by 23, and the final term is 42 pi by 23, by solving that equation there, we discover that in the arithmetic progression, the number of terms we have is 11. And so if we are going to add the imaginary parts of this here, we have a geometric progression whose first term is e to the 2 pi I by 23, with 11 terms, and whose common ratio is 4 pi I by 23. And if we bear in mind the usual formula, a times 1 minus r to the n over 1 minus r, we find that we have a e to the 2 pi I by 23 multiplied by 1 minus e 4 pi I upon 23 all to the power of 11, all over 1 minus e to the 4 pi I by 23. And if we do the usual kind of factorizations with this type of expression, we obtain this one here, which is e to the 2 pi I by 23 multiplied by all that lot there. And we have the factor e 2 pi I by 23 at the bottom. And then if we do some cancelling down, and if we start to put it in terms of sines and cosines, we find that we have e to the 22 pi I by 23 times minus 2i sin 22 pi by 23 over minus 2i times sin 2 pi by 23. And if I cast out, we will find that we will have cos 22 pi plus I sin 22 pi by 23 all over sin 2 pi by 23, and the imaginary part of that will of course be sin 22 pi by 23 sin 22 pi by 23 over sin 2 pi by 23. And the sign of pi minus x is the same as, and so if we use that, we obtain sin squared pi by 23 over 2 sin pi by 23 cos pi by 23. Oops. And that becomes sin pi by 23 over 2 cos pi by 23. And eventually we obtain half tan pi by 23. Now, in the second part of this question, we have to add sin 2 pi by 23 minus sin 6 pi by 23 and so on, up to sin 42 pi by 23. And so what we want here is the imaginary part of e to the 2 pi by 23 minus e to the 6 pi by 23 plus e to the 10 pi by 23 and so on. And so each of these terms is multiplied in turn by minus e 4 pi e to the 4 pi I by 23. So we have a geometric progression once again, similar to the last one, except this time A once again is e to the 2 pi by 23, R is minus e to the 4 pi I by 23, and then once again is 11. And if we fit into the usual formula for the sum to n terms of a geometric progression, we have e to the 2 pi I by 23 times 1 take away minus e to the 4 pi I upon 23 to the power of 11, all over 1 minus e to the 4 pi I by 23, and we do the usual tidying up and factorization, and we can find here that we can cancel those two out, and so we find that we have e to the 22 pi I by 23 times 2 cos 22 pi by 23 over 2 cos 2 pi by 23, and we will find that if we look again, that the imaginary part of that will be I sin 22 pi by 23 times cos 22 pi by 23 over cos 2 pi by 23. And if we look there, we find that that is sin 22 pi by 23 cos 22 pi by 23 over cos 2 pi by 23. And again, sin 22 pi by 23 is sin pi by 23. Cos 22 pi by 23 is minus cos pi by 23. And we will obtain from that sin pi by 23 times minus cos pi by 23 over cos 2 pi by 23, which is minus half of sin 2 pi by 23 over cos pi by 23, which is minus half tan 2 pi by 23.